Hello. Hello, everyone. My name is Rinku Sridhar, and with me is Lisa Ong. And today we are going to be talking about sensors and contextual awareness. Firstly, we want to thank you all for coming here to attend our session. Today, we are very excited to talk about how you can use sensors to turn your app into a crystal ball, an app that knows what your users are doing, an app that can predict what they're going to do next, an app that can give them the kind of information they really want, essentially turning it into a crystal ball. So yes, this is a mandatory slide. I have to remind you guys, please submit an evaluation after the session. Thank you. So today's agenda, we are going to talk about contextual awareness. We're going to talk about the new sensor APIs. Lisa's going to show you a bunch of cool demos on a bunch of devices ranging from Surface Hub, desktop, mobile, and IoT. We're also going to talk about how you can implement these in your app. We hope that you will walk away from this session knowing the basic sensor API pattern, all set to get started to write your app. So I'll talk a little bit of an intro of context awareness. I'm sure you guys know what it is, but just in case my second grade daughter decides to watch my session, I want to make sure it's interesting for her as well. So what is a context? A context is a set of facts about your user. What are they doing? Where are they? How are they feeling? Is the user walking, or are your users running? Are the users running because they're working out on top of a mountain? Or are they running because they are late for a meeting? So are they excited? Or are they feeling sleepy at 2 p.m. right after lunch? You know, that kind of information. So imagine what you can do if you have this kind of data about your users for a longer period of time. You can essentially have very intelligent information about them that can be used to predict and make very intelligent inferences, essentially, turning your app into that crystal ball that I was talking about. So now let's talk about how sensors can enable context awareness. So for this session, I'm going to create a fictitious user. Let's call her Kristen. And let's make an assumption that Kristen has given consent to your app to use her motion, activity, location data. Okay, so let's pretend today is Sunday and Kristen woke up at 9 a.m. in the morning, and your app knew about it. How? Using proximity sensors that detected her presence. So later on, Kristen decided to go to a shopping mall, and your app again knew about it using activity detection sensors. So while she was in the shopping mall, she took 2,000 steps. Your app knew about it using the pedometer sensors that was counting steps. When Kristen was coming back from the shopping mall, she was able to find her car really easy. How? Because your app located her parking location using activity detection sensors, barometers, and location information. So see how sensors have made Kristen's life so easy. So now we are going to go a little bit deeper into the APIs that we are introducing in Windows 10. The first API I'm going to talk about is the proximity API. So I talked about Kristen's presence that was detected. So that's using the proximity API. So the API will return the proximity state, detected versus not detected. It also returns the distance and range. So distance is the distance from the sensor to the object, and the range is how far the sensor can detect the object. So in Windows 10, we support both short range and long range sensors. So short range, you guys know about this. You have seen the phone when you are in a phone call, and when you put your phone near your ears, you have seen the display turning off. So that's using the short range sensors. And the long-range sensors can detect up to a much longer range, like the ones that you have on this Surface Hub, which detects up to 7 meters. a few applications. So one of the applications, like I mentioned before, is to control your display using proximity. Another application would be, so Surface Hub is implemented using proximity. You walk up to a Surface Hub, and the device will wake up. Similarly, you walk away from the Surface Hub, the device would shut down. So that's another really cool application. Another, you can also use proximity to detect if your device is in your pocket, so you can manage any accidental clicks. Like camera button gets accidentally clicked, but you don't want an action to take place if it's in the pocket. Another applications would be using cool gestures, and your app can react to it. Like a person can, your user can wave in front of the proximity sensors, and your app can provide something meaningful information to the user based on that gesture. Now I'm going to invite Lisa to do a demo on Surface Hub using proximity.
Okay, let me see. Can everybody hear me? Good? At the end? At the back? Okay. So does anyone not know what this is by now? Okay. So this is the Surface Hub. It has proximity sensors right about here and over here. Right now, the sensors are actually covered up with tape. I don't think you guys can see, but you'll see when I peel the tape off. So to demonstrate these sensors, what we're going to do is we're going to launch an app that simulates cold weather. So this is a snow falling app. It basically generates snowflakes. It's a really pretty app to stare at for maybe 10 minutes, and then you get tired of it. So what's supposed to happen is when I wave my hands in front, I'm supposed to be able to play with the snowflakes, just like I went outside and I'm playing with it. But nothing's happening, right? You just see it coming down. So now when I tear off the very cool cover from tape, look how the snowflakes actually react to me. I don't know if you guys can actually see, so let me do another super hand wavy motion here. Okay, got it? All right, so what's happening is these proximity sensors over here, they have about a 7 foot range.
7 meters.
7 meter range, sorry. And then it's basically detecting me as I'm within this. It probably can detect the first guy on the first row as well. Yeah, try. Try waving. All right, so here's the very quick demo to keep you guys awake. So let me launch to an, I don't want you to stare at this for the rest of the hour, so you can stare at a nicer looking thing like maps. So here's the Surface Hub demo.
4. Switch to 4, 5.
5, yep.
Okay. So now in case anyone was sleeping, now that we know that everyone's up. So now after the cool demo, we're going to show you how you can use proximity in an app. Actually, it's the slide. Sorry. The slide. Yeah. Here's my. Okay. So before we do that, we also want to give you an intro of the sensor APIs. So when we talk about each APIs, we will talk about the basic sensor API pattern. So as you may already know, the namespace to use is windows.device.sensors. So I'm going to talk about 3 major API patterns using proximity. So one is how do you discover a sensor? 2, how can you get a current reading of a sensor? And 3 is how can you get the reading changes? So for discovering a sensor, there are 2 ways. So one, there are devices which may not have multiple sensors. Like barometer, you will only find one barometer on a particular device. For that, what you would do is you would use the get default API. So you can see the API pattern over there. So use the get default function, and you can see the barometer being returned. So that's generally how you would, one way of discovering a sensor. So another way of discovering the sensor is, I'll switch to Visual Studio. For proximity, as you can see on the Surface Hub, there are 2 proximity sensors. So when you have multiple proximity sensors, you would use a device watcher. So here you can see this is the device watcher. So you're creating a watcher. So device watcher would enumerate any devices that's added or removed. and your app will be notified of that. So then you would subscribe to the added event, and you can see the on proximity sensor added is the event handler. So here is the event handler. So event handler takes in two parameters, the device watcher and the device information. Device information represents a device, and it returns a device ID. You can use from ID and find the sensor. So that's how you would discover a proximity sensor. So now I also talked about another API pattern, which is how can you get the current reading of a sensor. So I'll go into that. So this is the get current reading function. As you can see, for proximity, the current reading would be detected or non-detected, which is the proximity state. And you also get the timestamp along with it. So some sensors will have the detection distance. Like short-range sensors, you typically don't see it returning the detection distance. But for long-range sensors, you will have detection distance. If anybody saw the Surface Hub session, you notice they talked about two zones, zone 1 and zone 2. So depending on how close you are, you may want to provide different user experience. So that the detection distance will also be returned. So the next one I'm going to show you is the reading changed. So yes, this is the reading. So you can subscribe to the reading changed. So you'll be notified of any proximity state changes. So the event handler is very similar to the previous one, the get current, and it will return the detected or non-detected and the distance if it's available. So these are the three basic sensor patterns. This is how you would use any of the sensor if you want to get the current reading from a barometer or from activity detection sensor. You would pretty much use the same API pattern. If you're familiar with using accelerometer or gyroscope, you probably already know this. So now that we have seen these API patterns, I'm just going to show a quick demonstration of how you can use proximity to control your display. So for that, what you would do is you would use create display on-off controller. It's a one-line code. So when you call this, you can essentially use your proximity sensor to control your display. So I'm just going to run it so you can see it here. Okay, so once you enable, and if I put my hand over here, you can see that the display is turning off. So it's very simple to use. And I'm disabling it now and switching back to Visual Studio. So if you want to close the controller, you have to just call the dispose. And as best practice, you can always set the display controller to null as well. Yep, I think that's it with the proximity. Now I'm going to, so these slides, you have one slide. This is essentially what we showed you. It's for reference on how to use the get current reading and the reading and subscribing to the reading changed. So the next API that we are very excited to talk about is the activity detection API. So using activity detection, if you remember, again, going back to Kristen, we were able to detect that she was going to a shopping mall. So that is essentially using the activity detection API. So we support different activity states, like running, walking, in a bicycle, in a vehicle, fidgeting, which is stationary with slight movements, stationary and idle. What is the difference between idle and stationary state is, if the state is idle, then it means that the device is not with the user, but the device is left on a table. So that's the difference between this. And unknown is, if you don't know the activity, then unknown would be returned. So API also returns the most likely activity. API returns the most likely activity with the confidence of high or low. So you can also get 30-day history. So essentially, if you want to predict what the users are going to do next, you will have that exact history of what Kristen's doing. For example, if you know that Kristen is always driving, let's say from at 9 a.m. on a weekday, then you know that she's going to work at that particular time. So typical applications for activity detection is health and fitness tracking. Of course, knowing what the user is doing, they're biking, there is a lot of application in health and fitness. Another one is navigation, map, safe driving. So when you're in a car, you can tailor the user experience by making it, routing your text calls, not routing your text calls to the phone, things like that. You can essentially even build maps by seeing where the user is going, if they're taking any new routes and things like that. Then another obvious use would be power saving, because if you see that the user is idle or stationary, you don't need to fire GPS, or you can avoid any additional processing even the state is idle. So the next one is another demo. So this is a predestination app. This was built by Microsoft Research. They have multiple patents and papers written on the predestination algorithm. So we're going to use a simulator to demo that.
It's open. It's already open. Just was open.
Okay.
It was already.
Okay, so I'm opening the app. So I'm just going to run it first. Okay, so this is the predestination, the app using the predestination algorithm. Here you can see the activity. So the activity state changes will be shown here. And here you're seeing the status idle, so that's the algorithm status. Since it's going to be very difficult for us to demo a driving scenario, I'm going to use a simulation to simulate the driving. So again, what we are going to do is we are going to see how Kristen got to the shopping mall. So here you can see Kristen is, earlier it was showing unknown, and Kristen is now driving in a vehicle. So the predestination algorithm looks at the activity state in vehicle to start the algorithm. So now that it knows that it's the user is in a vehicle, it will try to figure out where the user is actually going. This is based on the GPS and also the route maps. The algorithm also has information on the user's past travels and trips. So what if, for example, if let's say Kristen wants to search for gas, the algorithm is going to provide the gas stations in locations where Kristen will have to take very minimal diversions. So what you're seeing, these triangles that you're seeing, is the heat maps that the app is creating, trying to predict where Kristen might be going. Another thing to note is apparently, so research says that only 1% of the trips uses navigation system to predict to know the destinations. So now you can see the gas stations are showing up, and that would be the closest. So you can see again here, this is by predicting where Kristen is going. Here's another gas station that's coming up. Okay, so now you can see that the activity has suddenly changed to walking, which means that Kristen has stopped her car and she's no longer in a vehicle, but she has started walking, probably towards the shopping mall. And then the app asks, are you parked, to confirm if she has parked. So this is how the Kristen's parking location was determined. So yes, so that's the demo on the predestination algorithm. And now Lisa's going to show you how to write code using activity detection. Thank you.
So let me get set up here, clicker. So the activity sensor APIs are brand new for Windows 10, and they basically have 4 patterns. The first 2 patterns are what we've covered earlier, which is getting the current reading, which is the current activity, walking or running or in vehicle. And the second pattern is to get the changes in activities. So if Kristen starts walking, the event handler is where you have code to save the parking location. The other two patterns that I want to go more in detail using Visual Studio shortly are getting the activity history. So basically, activity history is stored up to 30 days. It's stored in 1-minute intervals. So what you can do is you can basically reconstruct Kristen's day for the past 30 days if she had her tablet running. And this history is collected in the background, so it's not consuming a lot of battery. And the fourth pattern that I want to cover is actually using a background task to subscribe to activity changes. So even better option is you don't even have to force Kristen to run her app 24/7 in order to get changes in activity. You can just create a background task. So I'm going to come over here to go through Visual Studio. All right, so here's my desktop. And I created basically a Hello World solution before this talk. So this is a C# Universal Windows app that's created using the basic template. And all I added were two things. First thing is in the package manifest. Let me scroll down to where it is. We'll cover that later. I added a capability declaration for activity. So if your app needs to consume activity detection, it needs to declare this capability. And then the second thing I did was I did some very basic UI, which I'm going to show in a minute. Just walking through it, the UI has a couple of text blocks, very simple. The second text block shows what the history counts are, and then I have a list box with the history entries, and some basic data generation for the entries themselves. So if I were to just hit go, you will see a very super uninteresting app. All right. So what you're going to see in the next few minutes is how I fill in the history entries over here. Okay? So we're going to go back and stop this. All right, so UI is all done, so let's do the code behind. So every time I start writing code for the Windows APIs, I always worry about the namespaces, so let's add them. So the key namespace for sensors is windows.devices.sensors. The second namespace is what I'm going to use to calculate the starting point of history. So I'm going to scroll really slowly. So in the constructor for main page, super simple, I have a getHistory method. And getHistory right now is empty. So here I'm going to put calls, API calls to get the history from a starting point. Let's say I'm going to get the history for the past 15 minutes of her life. I'm cheating a little bit using snippets so I don't have to type. But I want to highlight this line right here. I hope everybody can see. I can zoom in, but I don't have a mouse. So get system history async is the API for getting the history for the past X amount of time. So for my starting point, I'm actually using 15 minutes. And I did some calculations using the standard APIs from calendar. So minus 15 minutes is 15 minutes from now is 15 minutes ago. So once I have the history, it returns a collection. So it's just something that I will loop through. I can get the count, next line, and then I can get the, basically get past the collection straight into the list box. So here's where I actually do the population of the list box. Also very simple, 2 lines of code. Basically, I take the reading, activity sensor reading, which gives me the current activity, so type walking, running, the timestamp, which I will convert to something readable, and the confidence. The confidence is basically, on this particular device, whether it thinks the activity is high confidence or it detected something that it wasn't very sure, so it does low confidence. Basically, The point between high and low is 50% right now. So above 50% is high and below 50% is low. So I think that's all I need to run to get history. I'm going to run, and we should see. I've been running the simulator on this machine, this laptop, so it has collected some history. We've been testing the app earlier on. So now you can see there are 15 history entries, 1 per minute. It started from more than 15 minutes ago, and then, more than 15 minutes ago, and then it's every minute. So she was doing a whole bunch. She was a very busy lady. So this is how simple it is to get history. And let's now jump to background tasks. So show of hands, how many people have written background tasks? No? Oh, okay. Maybe I should skip this session. All right, can't get out of it. All right, so to write a background task for activity sensor, basically, let's go back to app manifest again. It's a place I really like to start from. And background tasks are basically declared as extensions. So I have this ready to go. Basically, you say, I want a Windows background task. Here's my entry point. This is usually the namespace, and this is usually the class name. For activity sensors, we just use the general background task. We don't have a special type. So just keep that in mind. This is also shown in the SDK sample, so you don't have to remember. So now that that's taken care of, let's go to register the background task. So before I do that, I will add my namespaces, as usual. So all background tasks use the same namespace, windows.applicationModel.background. Very intuitive, I think. OK. Sorry, I scrolled down too fast. So windows.applicationModel.background. And then I'm going to uncomment register background task, and I'm going to leave history in. And here is where I would register the background task. The code will look a little bit of a shock because it's quite a lot of code, but I'm going to walk through it. So, all right. So don't panic yet. So basically, to start using background tasks, you have to ask the system, can I even run a background task? Do I have enough memory? Do I need internet? Will I have internet when I run my background task? So this is the purpose of the first line, asking for permission from the background execution manager. And assuming the background execution manager, he says, yes, you have enough resources, we can create a background task process for you. You get one of these two allowed options, and there's a huge blob of explaining what this means, but just look for the word allowed. And then the next thing you do is you build your background task. So I say, oh, okay, I'm going to call this some very generic name, and I'm going to use, this is the same entry point that you use in package app manifest, so which is the namespace and the class. So this is still generic background task stuff, nothing specific to activity detection until this point. So here's where we create the activity sensor trigger, which is the new trigger introduced in Windows 10 for activity detection. So using this trigger, you can subscribe to specific activities that you are interested in, and the system will launch your background task when the user switches to those activities or switches out of those activities. So for example, in this case, I'm interested to know whenever Kristen starts walking, or when she starts going into a vehicle, or when she starts or stops moving. So I'm adding these to my list of subscribed activities. That's pretty much all you need to set up the activity sensor trigger. Once you've done that, the trigger's ready to go. You tell the builder, OK, here's the trigger, and you register your background task. So that's all you need to do to set up the background task. Now I'm going to set a breakpoint here, because we're going to step through it later. Now, we've only talked about registering the background task. We need to talk about actually implementing the background task. So I'm going to pin Solution Explorer and add a new project. So all background tasks are actually Windows runtime components. So they are split off. It's kind of like a separate exe or separate DLL, except you can write, you can basically write your background task code in there, and it's very portable. So I'm going to call it task, which automatically lets Visual Studio set the namespace to match this, so it's a convenience. All right, so I'm creating it, it's churning. Okay, so now I have this Windows Universal component in my solution. And it popped open the background task. So I'm going to do what should be, which one is it? Probably this one. Kind of commonplace by now, adding the namespaces, application model, devices, sensors. This is for popping a toast. So I plan to pop a toast to Kristen whenever I know she's changed activities. It gets a bit irritating after a while, but this is good for demos. So for class, I'm going to get rid of that and do my class. So all background tasks will implement iBackground task. And I just happen to call my activity background task to match the package manifest declaration and to match the registration in main page. And all of these background tasks will implement implement a run method that takes in a task instance. So this is still the same across all background tasks, regardless of whether you're doing one for activity sensor, for timer, for geofencing. And this is also the common pattern. You take the trigger details from the task instance. It's kind of like, oh, why did you launch me? And then you get the information through the trigger details. And we have a class called activity sensor trigger details, which lets you read reports. And the reports are basically activity changes that have accumulated before the background task was launched. So sometimes background tasks may delay, may take a while for them to pop up because it requires creating a new process. The system may wait for a little bit till there's enough memory. So there may be certain activities that are accumulated past a certain time, and this lets you pull all the activities that you've missed since the user changes them. So the last code snippet is actually popping the toast. So we have the read reports, which returns a list. We get the count. And here I'm just going to show the last, most recent event. So I'm going to go to the second count -1 index. And then everything else here is just UI stuff, showing the toes. One thing to note, the reading is the same type as getting history, is the same type as getting current activity, is the same type as getting events. It's the same stuff. So you get the activity, you get the timestamp, you got the confidence. So I think I'm done with the code. Let's set a breakpoint here as well, so that when we run, we can see things happening. And the one last thing that I always forget, and it gets very embarrassing, is to add a reference. So what I'm doing here is I'm going back to the main app that registered the background task and adding a reference so that this task .winmd file gets packaged into the app and registered and all that goodness. So that's all. And now I'm going to run this and walk through just the registration part. So let's see. Okay. So now broken in Visual Studio in the register background task method. So stepping over. So I'm going to say, am I allowed to run a background task? Yes. Demo gods are happy today. So now I'm going to register activity sensor trigger, set some settings, very basic stuff. Okay, continue. Oh, the background task launched. Sometimes I have to go back and trigger an event, but today it's really happy. It actually ran the background task. So in case you're not sure what just happened, I'm actually in, let me just minimize this. I'm actually in this guy right now in the class1.cs file, and this is the background task that's being run. So let me just hit continue, and there you go. You see toast being popped. So the background task did run. Now the last test, because this is a background task, I don't expect this app to run continuously. I'm going to stop debugging, and then I'm going to trigger the simulator. First, let me go away. All right, so everything's not running. Yeah, it's not running. So I'm going to go back and click on the simulator, which is nice. So this just simulates activity. And here you go. The background task actually launched, found 2 activities, and showed the toast. So that's it for the Visual Studio walkthrough of activity sensors. Switching back to PowerPoint. Yeah, we pretty much covered the 4 things, and this is just for your reference.
Okay, so now we are moving on to the other sensor APIs that we have here to talk about. The next one is the pedometer API. So when Kristen was in the mall, we noticed that the app was counting her steps. So that's using the pedometer APIs. So the API will count both walking and running steps. You can also get the duration of the steps taken, which is the active time that's spent. So very similar to the activity detection, we also support 30-day history if the hardware supports that. Typical application obviously is in this health and fitness tracking. The users will not require a fitness gadget. The device, phone, or even tablets could help counting the steps. So another application is, so let's say you can actually combine both the fitness gadget, the wearable device, along with the data that comes from the other devices as well. So just in case the user, Kristen, forgot her, let's say she's using the band, she forgets that, or she forgot her phone, then it still counts because this is supported even on desktop. So if she is taking her laptop with her, she still gets her step counts. So again, this is for your reference on how to use the pedometer API. So Lisa has gone through the activity detections. It's very similar. So you can see, you can subscribe to the reading changed event and get the changes in the step count. And the step count history, you can use the get system history async to get the history for pedometer as well. So Lisa's now going to do a quick demo of the pedometer on both desktop and mobile.
Okay, so here we have 2 devices. On my left is a Intel Cherry Trail tablet. It's running, well, it's literally running activity detection and pedometer on a universal app. And here on the right-hand side, it's a Qualcomm prototype Windows Phone device running Windows Mobile, also Windows 10. And both of them have counts here. The activity one is not showing up, but trust me, it does. So what I'm going to do, so remember there's 119 steps and 223 running steps, 119 walking steps. I'm going to go walk around the block. Out of the... Okay. Didn't really show anything, but I need to run. Oh, yes, there you go. It showed 14 steps. So it took a little while, and I was shaking it. I'm very good at making it do vehicle. So here's the other device. I'm going to walk around again. Very, very active demo. Yeah, this one takes a little while, but trust us, it's
You want to walk a bit more? Try
okay.
A couple more minutes. So because the step counting takes a while. There is at least 10 seconds before it actually starts. Is it?
Yeah, it's showing. So it used to be 4, now it's 6. So I
took 2
steps. I walk very slow.
Yeah.
Okay. Yeah, so these devices are coming, and we're having a lot of fun.
It's going to really work.
Okay.
Yep. Thank you, Lisa.
All right.
So the next API that we are very excited to talk about is the barometer API. We are introducing barometers in Windows 10. So barometer API will report the barometric station pressure. So we also have a derived altitude altimeter API, which will give you the elevation changes or the altitude changes. So typical applications will be in health and fitness. So you have the step counts from the pedometer, but now you also have the altitude data. So you know if the user is climbing a step. So with that, you can make your calorie calculations much more better. So there are research papers written on this. Another one is, it can also actually, you can trigger based on the pressure changes. Some people who have migraines, it's triggered based on the pressure changes. Hypoxia, things like that can be used in for health areas by determining what the pressure is. So it'll be very easy to create applications that supports those. So the next application is in indoor location and floor sensing. So using the barometer and the altitude data, you can figure out what floor the users are, whether they are either going up or down, or are they taking escalators, or are they taking the steps? Because by using the pedometer data, if you don't see the step counts, but if you just see the altitude changing, then you can kind of infer that it is probably they're going in an elevator or using an escalator. So when we were on a trip to San Francisco, when we were on a plane, we tried to look at the barometer reading. It was really funny when we did that. 700. Yes, 700 is what showed up. So the sea level pressure would be 1,013 to 15 most of the time. Okay, now another very common use case is for weather forecasting. If somebody wants to go for fishing, like what is the right pressure, by looking at that, then then you can go. So again, we have it here for reference. Since you have seen all the API pattern, by now you can see, it's very similar. You can use the get current method to get the default sensor, using the get default method to use to find the barometer. So you can use the get current reading to find the current reading of the barometer. You can subscribe to the reading change event to get notified of any changes that happens in the sensor data. Very similar, you can use the altimeter as well. So the next API is the custom sensor API. So let's go back to Kristen again. So Kristen is taking a trip to Tokyo, and she has severe allergies. But when she is in Tokyo, she has an app that gives her live information on the air quality and pollution index of every city she visits. So we didn't talk about an air quality sensor today, and we are now planning on introducing one. But what we are introducing is the ability to create universal Windows application for a completely new sensor. So it could be a UV sensor, it could be an air quality sensor, it could be a pollution sensor, carbon monoxide sensor, so any sensor out there. So hardware manufacturers can add a completely new sensor without depending on a Microsoft OS release. So you will use the application developers can use the exact same API pattern that you have seen here. You would use the same get current reading to get the current readings even on a custom sensor. You will subscribe to the reading changes to get the changes in the reading. So it's a very, very similar. So imagine what you can do in an industrial scenario over here, right? So the picture that you're seeing here is of a person using a device which has multiple custom sensor, and he's in a hot house. So here it requires very optimal temperature, humidity. It's a very controlled environment. So if he has an app that can track all of this and all its sensors on this device, it's really, really awesome for applications like that. So what Lisa's going to demo right now is using custom sensors on an IoT using Miniboard Max.
Okay. So here we have a Miniboard Max device. It runs Windows 10 IoT edition. And we have over here a UV sensor. It's a custom sensor. We don't ship, like Rinku said, we do not have a Windows.devices.sensors.uv sensor. So instead, we have the custom sensor API, and there's an application that's running on this system and a driver that's written, a universal driver that also talks to the UV sensor. So I'm going to switch over to the number 7. So, of course it's not. Let's see. I may have to power cycle this, so let me reset. Okay. All right. So now you get to see the boot sequence of this device. It's really quick. This proves that it's running Windows. There you go. Okay. Okay. The anticipation. Show up, or not. This is not the app, this is just a loading screen. Okay, so here we have a full screen desktop. This is what the IoT edition boots to, and you see I can use my mouse. It's plugged in here. To be very careful. So I have a bunch of apps here, and the one that I need to select is all the way down to the bottom. So, yeah, and it rebooted. Oh no, it did not, okay. So this is the UV sensor app. It actually uses the custom sensor API. It sets the report interval, which is the interval, how frequent you want the events. At 1,000 means 1 second, so this is in milliseconds. And right now the UV levels are very low, and we're all not in danger of UV exposure. So let me find the flashlight, okay. So I have a flashlight here, and the sensor's right here. So if I don't want to switch over because I'm gonna have to. So if I shine a flashlight on this, it takes a couple of seconds. Yep, here you go. So as I shine even brighter, you see more higher. So this is basically a universal app also running on this device. We can run the same universal app on desktop, on phone, with the custom sensor API, and it would all just work. Okay, so switching back to PowerPoint. All right, next slide. All right, so Rinku already talked about all the patterns, and this is going to sound very familiar to you. So, you know, the key thing about custom sensors is actually finding the sensor, because you don't know what this is beforehand, and you don't know what properties and what readings it can give. So the way we defined it is you just use a GUID that the driver provides and publishes somewhere, or you talk to the driver developer. You get that GUID, and they use that to find the sensor. So in step 2, you see get device selector. It takes the GUID for the UV sensor. And then once you found the sensor using create watcher and so on, and you get the reading, you use a string key to identify the readings that you want to get from the sensor. In this case, this would be the UV level. It's a key that the driver implementer defined, and the app developer would just take that key and say, oh, okay, I know this is a float, so I can just convert it to a float. So there is some contract between the app and the device that you need to know of. That's by nature of being custom. But other than that, you know, everything else, the constructs are the same, the patterns are the same. So, and we do have SDK samples showing how this is done in greater detail for both drivers and for both apps.
So the next topic is sensor batching. So we are introducing sensor batching on accelerometer with Windows 10. So from now on, there will be 2 ways of getting sensor data. So one is continuous, and the other one is batch mode. So continuous, we already talked about. If you subscribe to a reading changed event, you get the data continuously, or the data will be streamed based on a periodic interval. So let's say you decide to have your report interval as 50 milliseconds, then you get the data continuously every 50 milliseconds. So that's continuously getting the data. So batching is, instead of getting the data continuously, if the hardware supports batching, which is if it has deep FIFOs or if it has the buffers, then it will buffer the data and send the data only in batches, essentially saving power. So what the developers need to do this is, so you will need to decide on what is your report latency. Essentially, what is the latency or the delay that your app can tolerate before it can get the sensor data? And this will also depend on the max batch size, which is the maximum buffer that the hardware has. So can the hardware, let's say, buffer up to 200 events, or can it buffer up to 300 events? So depending on that, the batching, you will know like how much events can be batched. So if the max batch size is 0, then batching is not supported on that hardware. So let's talk about typical applications. So obviously, it's a very power-saving feature because the application processor will not be running continuously, but only when those batches are sent. So if you have an app that, like a gaming scenario where there's a lot of foreground action, then batching is not recommended. It's not going to help you that much. However, if you have an app which has, like, let's say if you want to do sleep tracking or sleep monitoring or activity detection in the background when the display is turned off, then it can really significantly save you power. So now moving on to the next topic, which I'm sure you have seen in the keynotes. So starting Windows 10, we have this concept of Windows bridges. So you can start reusing your Android and iOS apps and bring them onto Windows. So there are two efforts. One is Project Astoria, which is about reusing your Android code. So for sensors, it's going to be really easy for you guys because most of the key sensors APIs are supported. Accelerometer, gyro, magnetometer, proximity, and the activity detection, which we just talked about, is also supported. So it will be very easy for you to reuse your existing Android apps. Similarly, the next, another effort is the Islandwood. So for that, we prioritize mainly gaming scenarios. So you'll be able to reuse your apps that uses accelerometer, gyro, and magnetometer. So please, for more information, please attend their sessions. I know the Astoria session is sometime today evening. I'm not exactly sure of the timing of the other one. So again, how many of you are already using the Sensor Core APIs in your apps? Okay, I see. 2, okay, great. So so Lumia Sensor Core APIs is something we released in last year to support the activity tracking features. So we are very excited to say that in Windows 10 now, so these features would be supported on all devices. You've seen in the keynotes. So these will be the universal Windows platform APIs. So it works on devices ranging from desktop, mobile, IoT, HoloLens, all of those. All future enhancements for the activity detection and pedometer features will be using the universal Windows platform APIs. So the guidelines to the developers is if you are building a new application, definitely start using your the universal Windows APIs. If you would like to target the legacy older Lumia phones, then you may want to consider using the Sensor Core APIs. So the universal Windows APIs are supported on devices starting the Windows 10 devices and future. So we are looking into supporting the older devices as well, but and we are working on a plan for that. So now I'm going to invite Ali here. He's going to talk a little bit about the MS Health app and the new REST APIs that his team is developing.
Hello. I don't know if we have a lot of time, but I'm going to go very, very quickly. Those of you who don't know me, I'm Ali. I work for the Microsoft Band, Microsoft Health team. If you don't know about Microsoft Band, it's an awesome wearable, all-day wearable that collects a lot of data about you using sensors. And all of that data goes up to our Microsoft Health service. The Microsoft Health service does a lot of algorithms on the data that you get from the Microsoft Band, and it shows it up into the Microsoft Health apps, which run across all platforms, and they basically give you a graph and charts of your activity and give you a detailed view of your activities. So one of the things that we did was we made Microsoft Health, the service, in a way that it is more extensible. So we wanted to get data not just from Microsoft Band. We want to make it so that we can get data from a broad range of devices. That way we can get users who are already bound to other devices and other apps and services to also become members of the Microsoft Health ecosystem. So the things that we did was when we heard about the pedometer API that are available on Windows, and I'm not nearly as much fun to watch while I walk as Lisa is, so I already did a bunch of walking. So one of the things that we did was we said that if someone is not using a Microsoft Band, but they have some of these phones that are capable of providing motion APIs, can we do something to get data from those devices and provide value to those users? So I'm going to go in here and let's see. Can you see that?
Switch to.
Yeah, it's switched over. So This is a phone that I've been carrying around all day, and it's collecting. We wrote a background task to periodically collect data from the pedometer APIs, and it'll show us. So on my band, for example, right now I see about 2300. It's syncing right now. So this phone is not connected to any Microsoft band. It's basically just using the pedometer APIs. And as soon as it updates, you can see that it's showing 2100 steps that I took the whole day. So that's just the data that we got using the pedometer APIs. But just because we have this data now, you can see that we can actually provide more value to the user. So we can automatically collect based on that, the number of steps, the calorie information that was collected. If you go deep into this, you can see that now using the pedometer APIs and using the steps, the Microsoft Health service can now provide more value to the users. As soon as this chart comes up, you will see that we can tell you calories burned during the day. We can get you historical data about your calories. If you have some goals set with Microsoft Health, you can also get those goals. So just by using some APIs that were available on the phones, even if you don't have a Microsoft band, we can take that data, provide more value to the users. So the key takeaway is users really are getting and demanding more and more context about everything that they do. So we need to enrich our applications and our services to get data about sensors and other things that are providing information about the user and enrich the experience of our apps and services using that data and provide value to the users. So Windows sensor APIs are a great way to start. If you have apps, you can use that apps and enhance the experience of your apps using these APIs. If you have services, Microsoft Health will soon be opening up Microsoft Health APIs, which will provide you a lot more information about other services or other activities that the user is doing. So things like your runs, your workouts, your sleep activities, that kind of data, your services can pull those in and essentially enhance the experience of your apps and services. Thank you.
Thank you. So switch to 1. All right, this is the last slide, we promise. Thanks for being so patient and staying throughout the whole talk. I know we're running a little short on time, maybe 2 minutes. So the last slide, I want to cover additional things that are not very obvious when you talk about sensor APIs. I just want to point these out because these are new features that we're converging towards for Windows 10. So the first thing is the reading transform property. And the reading transform property is something that's added to a bunch of sensors, such as accelerometer, gyrometer. So basically what it lets you do is you have sensor data that you want to align to a particular orientation. So if I have a device like this giant brick, imagine this is a very sleek looking phone. So if I'm writing a game for this kind of device and my axes are always aligned to this, when I want to transfer to a device that's like this, I don't really want to do a bunch of math. So I use reading transform to force the axes to be this way, and then the user will just naturally use the game this way. So that's reading transform. And then the other things, real quickly, sensor data is actually now streamed consistently across platforms. So what that means is if you're on a desktop machine, you're down on an IoT device or on a phone or Surface Hub, you get the same behavior. Just remember to set the report interval or use the default if you don't care. Basically, that sets how frequently you get the data. And the third thing is all these devices that we showed today, you don't have access to them. You don't have access to those devices that I was running around with. What do? Well, use simulators. So simulators are your friend. You can download the sample drivers for sensors from GitHub for the, I think they're called Universal Driver Samples repository. And you can build them using Visual Studio, using the Windows Driver Kit, and install them on your system and test with it. And the last thing is users can actually go into privacy settings and turn off access to certain sensitive data for your app. And you can embed URLs into your app so that you can tell the users, click here to go turn on location or turn on motion in the future. So just some quick things to kind of keep in mind so that the user doesn't get confused. Last slide, okay. Yeah, so some call to action. So we have a quick start challenge for pedometer. Basically, it walks you through how to create an app to count steps. It uses the pedometer sample driver that I talked about from the Windows Driver Kit. And we've got links to the universal driver samples, and we've got about 15 universal SDK samples for sensors. So we have a whole massive list of samples and API reference on MSDN. And related sessions, Project Astoria, which is running Android code on Windows devices, and iOS, which is called, yeah, I think that's happening right now. So thanks for attending our talk, and hope you watched their recording. So I think that's it.
Yes, and we'll be available in the Insiders Lounge?
Yes, in the Insiders Lounge back over there. We have
if you have any
44 seconds.
questions.
Yep. All right, thank you guys.
Yep.
Thanks for being so
patient.
patient.